Oh, we are working on the 2020 KZN prelim paper 1 today, like the latest one, the one that was written like a few weeks ago in September. So yeah, I don't think there's any time to waste here. It says here solve for x. So I mean, solving for x, this is quite a weird question, but the key thing here is they said solve for x where x is a rational number. So the big issue is, firstly, we are given x with what do we have on that? Let me, why are so many papers? There we go, much better. So yeah, we're given x and pi. Yo, how do I put this now? Pi minus x, right? So here we have pi minus x, and then we know that this is equal to 0. So the big issue is, you could think to yourself, well, we have two things, right? This is equal to 0, or you could basically say this, but the only issue is this here is not valid. You see, you would want to cancel out this answer. The reason is pi is not a rational number, not a rational number. You see, pi is not a rational number. Here they want us to get a value for x where x is a rational number. So pi is not a rational number, so our only answer here is x is equal to 0. That's going to be for 2 marks, and that's for 1.1.1. Let's move on. Let's move on. We don't have time to waste today. Let's see if we can do this in like at least, you know, less time than the others. So the next issue here is they want us to, what do they want us to do? They want us to solve for x again. However, our answer, we need to round it off to 2 decimal places, and they have given us, it looks like that's just a basic quadratic equation. So with that equation, we are just going to use the quadratic formula. There's really not much to it. So this being given, we know that we can take everything to one side, and then we can just use our quadratic equation. So the point or the idea with this tutorial for today is I'm literally going to try and like blaze through the paper. Yeah, like very little distractions in this paper. So let's see here. B, this is going to be h squared minus 4ac, and also avoid a lot of dumb mistakes. That's a 7. And then here we have 2a, which is a negative 3. So if you put all that in your calculator, that should give you x is equal to negative 0.69, or x is equal to 3.36. This is quite straightforward. There's really not much to it, and let's just keep moving on because we ain't got no time to waste. So 1.1.3, we have a third there, and there's just, it's also a basic question. That's how you'd want to look at a question like this. The more you can trick your brain into assuming that most questions are basic, I feel like it will reward you, by not overthinking. So the first thing we can do here is, well, we can take the x over. The reason we would want to take the x over is, usually when you have something under a square root, you want to isolate that. So here we can just square the left, square the right, and then here we can clearly see that we're going to FOIL this out. And then here that is going to leave us with 11 minus x. Let's see here, 1 times 1 is 1. And then 1 times x is x. X times 1 is x. X times x is x squared. 11 minus x. And then let's see here. Let's take everything to one side. This is going to be x squared plus 2x plus 1. And then minus the 11 there. And then plus the x. This is equal to 0. And then we know that this is going to be x squared plus 3x, and then this is like 11 plus negative 11 plus 1, that's like negative 10. And then this, you see, we can also just use the quadratic equation, or we could even just factorize this, factors of 10 that can give us a 3. It is basically 5 and 2. Now the idea is 5 minus 2 gives you a 3. So this has to be positive 5, this has to be minus 2, and then there you go. Or you could have just used the quadratic equation. It's your choice. X is equal to negative 5, or x is equal to positive 2. Straightforward, nothing much to it. The only issue here is they said that, you see, our initial question has a square root symbol there. So let's see here. we should solve for x here, and we should also try and double check our answers, if our answers are going to hold in terms of our expression. So let's test -5 quickly. 11 minus -5 minus -5. Let's see if this is equal to -1 or +1 rather. So this is going to be 11 plus 5, right, under square root, and then this is like plus 5. And then funny enough, if you check here, this is just odd, but look, this is 16 under square root plus 5 is equal to 1, and then this is like 4 plus 5, and you see that's not equal to 1. So this answer is not valid, the -5. So we can scratch that one out. The 2 we can have here 11 minus 2 equal to, this is going to be, no, x is a 2, so that's going to be -2 there. Let's see if this is equal to 1. And then let's see here, this is going to be 11 minus 2, that's like 9, and square root of 9, that's like 3. So yeah, this is like 3 minus 2, which is definitely equal to 1. So this works out, this does not. So remember, anytime you deal with square root symbols, always try and remember that you have to test your answers. If you don't test your answers, you're going to be in trouble, and you don't want that, you see. So with our next question, just by looking at the way this next question is laid out, it looks as though we are going to use, well, just by looking at it, I mean, I'm looking at it for the first time, it looks as though we might end up using the K method or not. But let's try and not overcomplicate anything. The one thing that stands out here is we have x as an exponent in 2 cases. So what I prefer to do is usually have those expressions close to each other. So I would take the -3x, the -3 to the power of x minus 2 over, so it becomes a plus, and then the 57 stays alone. Now, for the reason for doing this, as you see here, this is 3 to the power of x plus this, we can split it up into 3 to the power of x times 3 to the power of -2 using our exponential laws, because here there's a base with an exponent which has 2 things, you see. So we know that if your bases are the same, you can add the exponent. So bases are the same, we know it can end up like that. So here now you can clearly see that 3 to the power of x is a common factor. So here we're going to be left with 2 plus 3 to the power of -2. This is 57. Well, technically here you can just divide both sides by 2 plus 3 to the power of -2. This is like 2 plus 3 to the power of -2. So this and that cancel each other out. This is like 3 to the power of x, which is equal to, well, in your calculator, you can literally just throw all that in the way that it is, right? Like fraction, 57, 2 plus 3, hey, why did I press alpha? Onto the exponent. Let's see here, this is to the power of -2. So this here is 27. Thank you very much. So 27, the good news with 27 is we know 27 is 3 to the power of 3. And then obviously here, therefore, x is equal to 3. Quick, simple, straight to the point. You get your marks and you move on to this inequality question. So on the main channel, Bright Young Brains, one of the latest playlists as of this recording is the playlist on inequalities. So with this inequality, they want us to just solve for x. Now this is a simple inequality in the sense that we have a smiling parabola given, so we need to get its roots first before we can solve this question, because this question is literally saying, where is this graph having y values that are below 0? So we have to give these y values in terms of x, in the sense that we have to say this graph is below 0 or equal to 0 starting from this x value until this x value. So we need to find these 2 x values, and to do that we just need to solve for x. You see, equate this to 0. If you take out x as a common factor, you basically have 4x here minus 5 equal to 0. So x is equal to 0, or we have 4x minus 5 equal to 0 here, and then you're clearly seeing that x is going to be equal to 5 over 4. So technically this is 0, this is 5 over 4, and our graph is below 0 from 0 until 5 over 4. So here your answer, you basically need to say that your x values need to be bigger or equal to 0, you see, because x is starting here. So your x values need to be bigger or equal to 0, or your x values need to be smaller or equal to 5/3 and 5/4, sorry. And I know you usually like to write x as an element of 0 until 5/4. This is also valid. You can also write it like this. It is totally 100% fine. Or you could even have said x is bigger or equal to 0, or x is smaller or equal to 5/4. So all these three options are valid. So you can write it like this, you can write it like this, or you can write it like that. I usually prefer doing this because it's a preference. There's really not a reason for it. So 1.2, and you can see, compared to the other two papers, hey, today we're just moving, just moving along. So here with our next question, this is clearly asking us to solve these two simultaneously. And with solving simultaneous equations, the big issue is our signs. We just need to be careful because look, it's a 5-mark question. It's pretty straightforward. There's really not much to that question. It's 3 marks given. So we can isolate y here. This is just going to be 3 minus 2x. And then we can throw this into this equation, you see. So this is going to be like 3 minus 2x, the whole thing squared. Oosh, snap, my bad. This is like x squared plus 3 minus 2x. That's where y is, and then plus x. So because this is a plus, we don't have to put this in brackets because it's going to be the same thing anyways. But if this was a minus, it would be best to put that in brackets. So here we have 3 minus 2x, the whole thing squared. So that's what we have here. And then here, if you simplify, you're going to have x squared. Let's see here. Minus 2 plus 1, that's like minus x plus 3. And then here 3 times 3, that's like 9. Minus 6x minus 6x. And then plus 4x squared. And then let's see. Here, it's easy to just simplify here. 9 minus 12x. Yep, 12. Plus 4x squared equal to x squared minus x plus 3. And then obviously it's easier to take your values to the side that has like the biggest values and stuff. So this is just going to be a plus x, and then this is 9 minus 3 equal to 0. You see, I took these and I was putting them in order. So you see, this is that, and then when this goes over it becomes a minus. This is that, and when this goes over it becomes a plus. This is that, and when that goes over it becomes a minus. So here we're ending up with 3x squared, and then minus 11x, and the 9 minus, this 9 is a plus, you see. 9 minus 3, that's just 6. 9 minus 3, that's 6. So this is going to be a positive 6. Like that, equal to 0. Now, what we have here, we can easily just work that out using our quadratic formula, or you could even just simplify, but I use the quadratic formula for stuff like this. So x is equal to minus b squared minus 4 you see, I wrote it wrong. Oh wow. X is equal to minus b plus minus b squared minus 4ac over 2a. And then, so here we're going to have negative 11, and then plus minus b, which is negative 11 squared, minus 4a. A is, what is a? A is 3, c is 6, the whole thing over 2 times 3. And then, let's see here. If we put all this into the calculator, we're going to get our x values as 2 over 3, or our x value needs to be a positive 3. Now the good news is for the y value, we can just take what we have here and throw in our values for x. So this is like y is equal to 3 minus 2 with x there. And then this is like 3 minus 4 over 3. Or we'll just simplify that just now, and this is like y is equal to 3 minus 2, and then throw 3 there. This is going to be 3 minus 6, which is like minus 3, which is fine. This, if you put that into your calculator, you should get 5/3. 3 as your other value for y. So you see 1, 2, 3, 4 solutions. They'll give you 5 whole marks for that, because that's just a 5-mark question. So let's just move on to question 2. There's no time to waste, as we mentioned. I don't know, maybe one day I'll actually do one of these in like 3 hours, even while narrating. I just need to get fast, like super quick, like the Flash. But anyways, question 2 says, we have this sequence. It says the first 3 terms of the first differences of a quadratic sequence are 102, 108, 114. So before even looking at the question, they said these are the first 3 terms of the first differences. So what you want to think to yourself is, you have 102, and then you have 108 there, and then you have 114. So the big issue is, before these values you have like original terms. You see, you have like original terms. You have like term number 1 here, term number 2 there, term number 3 there, term number 4. So you see, I'm not even looking at the question yet, but we just need to get an idea of what's going on. We have a term here, another one there, another one there, and another one there, and this is a quadratic sequence. So we know that t2 minus t1 gives us this value, this minus that gives us this value, this minus 1 gives us this minus that gives us this value. Now we know that this is like the original sequence, ORG sequence. And then what we have here is the first differences. And then under this, we're obviously going to have the second common difference. I mean, come on now. Second common diff. Now this second common difference, we can even just check out what it is, because it looks like it's going to be 6, because this minus that gives us a 6. Okay, so this is what we have technically from the get-go. Let's see what they want us to do. They said, determine between which 2 consecutive terms is the first difference 2022. Okay, determine between which 2 consecutive terms is the first difference 2022. So firstly, just to give an idea of what the question is saying, you see here, when the first difference is 102, the consecutive terms is term 1 and term 2. When the first difference is 108, the consecutive terms that are resulting in this difference is term 3 and term 2, going on and on and on. So basically, all we're going to need to do is, we need to think of this as technically as an arithmetic sequence, and then we need to find out in this sequence where is 2022, and we can easily just use our Tn formula. You see, this one is quite blunt, straightforward. Our a value is 102, our n is what we're looking for, because we don't know where this term is. Tn is 2022, because this is the actual term and we're looking for its position. And then our common difference is clearly, as we said, just 6. So let's just work this out. This is quite simple, I guess. If not, it is getting simple. And then n, we're looking for it. D is a 6. Now the idea is we need to multiply the 6 inside. This is going to be 6n minus 6, 2022. And then here, solving for n, it means let's take everything that is not n to the other side, you know. This is 6n. And then the big idea here is we can just use our calculator. 2022 minus 102 plus 6. That's 1926 on the calculator. 1926. And then this here we're dividing by 6. So this here divided by 6. Let's see what our value for n is. Our value for n is clearly going to be 321. So yeah, so if this is going to be term 321, what you want to recognize is, if, let's see here, you see this is like term number 1, this is term number 2, this is term number 3. So if you have term number 321 somewhere here, it means that this term is between 321 and 322. You see, if we use this same analogy, you see term number 1 is there, term number 2 is there, term number 3 is there. So if you have term number 321 here, it means it would have been between 321 and 322. So here you see we need to say therefore the consecutive terms, I don't even know if that's spelled correctly, is it? Let's check that out. Where's the question? Yep, the consecutive terms would would be 321 and 322, just by looking at this ideology. See, 1 2 3 until 321. So for this one it's between 1 and 2, for this 2 it's between 2 and 3, so for this 321 it's between 321 and 322. So that's for 2.1. 2.2, hey, we're moving today, we're moving. If you have never gone through one of these or used these to like double check an answer that you did not understand from a memo, then hello. But yeah, this one is quite fast as compared to the other ones. Determine the nth term of the sequence if it is further given that the third term of the quadratic sequence is 310. So we need to get the general term of the quadratic sequence. So this is the first differences of our quadratic sequence. They want us to find the actual sequence of our quadratic sequence now. So we know that for this question, I mean, the one thing to remember is that our general term looks like this. Tn is equal to an squared plus bn plus c. Now the big idea is, here we know that this is equal to 2a. This is equal to 3a plus b, and then whatever the first term is, it is equal to a plus b plus c. So to take things nice and slow, let's start from the bottom. We know that 2a is equal to 6, so this is going to be a is equal to 3 because you divide by 2 on both sides. And then here for 3a plus b, 3a plus b, we know it is equal to 102. So our a value is at 3, so let's see there. This is going to be 9 plus b equal to 102. And then 102 minus 9, that is clearly going to be 93. Hey, let's just check with the calculator. Yep, 93. That's a big value for b, eh? B is going to be equal to 93, but I mean, we're dealing with big numbers, so it's okay. It's okay, I guess. So the one thing now is, luckily for us to get our value for C, I don't think we need to use this. We can just use our formula for now, because look, Tn, we know it is equal to a is 3, right? So this is like 3n squared plus 93 plus c. Now the good news is, you see, they gave us a value in the sequence. You see, they gave us n and Tn, which is here. You see, n is 3 where Tn is 310, because they said 310 is the third term in our sequence. I forgot an n there. So this is 93 with 3 where n is, and then here we're just working out a value for c. Now if you throw all this into your calculator, this is going to be like 9 times 3, which is like what, 27. 93 times 3, let's see what that gives us. That's like 279 plus c. And then if you take everything to one side, our value for c is, let's see here, 27, you minus 279, you minus. Our value for c is going to be equal to positive 4. So here c is going to be equal to 4. C equals 310 minus 27 minus 279. Yep, our value for c is equal to 4. So here we can then say, therefore, Tn is equal to 3n squared plus 93n plus 4. And that's going to be your answer. Whew, yeah, answer's blazing today, on fire. So that's that for 2.2. I think we should move on to bigger and brighter things, I guess. So let's see here, what's the next thing. Question 3 is the next question. So with question 3, we need to, what do we need to do? Well, it's another sequence and series question, obviously, because usually always have 2 of these at least. So we have the first 4 terms of an arithmetic sequence. I feel like, you see, the arithmetic sequence part of this paper, I mean, let's not lie, it was quite, it looks like it was quite, I don't know, that first question, it was okay, I guess. It didn't, I think depending on where your head would have been while going through that question, you would have felt it was a bit tricky, but we're done with it now. So the next one here says we should determine, we have a sequence, clearly it's going up. Yeah, it looks like it's getting higher and higher and higher. It's an arithmetic sequence, so we know there's a common difference. They say to find the value of the nth term. Getting the value of the nth term is always the easiest thing you'll ever have to do, because getting the value of the nth term means you write down your formula. That's on your formula sheet. You see, your formula sheet has your general term here. You see up there. Where is it? Where is it? Where are you? Hey, show yourself. There we go. Boom. So you just write it out, and then all you need is a value for a and d. That's literally all you need. So firstly here we can already see that our value for d is going to be this value. You see, t2 minus t1. So this is like this value minus this value. That's like 1/5, because you see, I mean, you know, so d is 1/5. I mean, it's clearly given. And then our value for a is also given. It's just 2/5. So just throw those into your formula and then simplify if you want. So this is like 2/5 plus n minus 1, and then this is 1/5. And then this, if you simplify, it's just going to be 5/2 plus 1/5 n minus 1/5, because you multiply that inside. And then here, if you simplify, it's going to be 1/5 n plus 1/5, because this minus that. There's your general term. It's quite simple, and it's for how many marks? It's for 2 marks. You see, I'm also trying to give the idea that easy questions, just move, you know, don't even waste any time. They want us to calculate the sum of the first 30 terms. Wow. Okay, that's a nice question. Easy, quick, 3 mark. You will take it and you run. So with our sequences and series Sn formula, here technically n is going to be 30. I mean, a, we know it is just 2/5. D is 1/5. A is, oh, we got A. I got everything. So we're just looking for S30. So here this is like 30/2. This is like 2/5. N is like 30 minus 1. Our value for D is 1/5. And then I prefer usually just putting everything in the calculator. Just throw it all in the calculator. Like, don't overthink anything. It's really not worth it. So if you put everything into the calculator, you're going to see that the sum of the first 30 terms is just going to be equal to 99. So you write it out and you keep moving on. There's really no time to waste. So here now it is said that we're given another sequence, or a series if you want to refer to it like that. So this series, the reason why we're calling it a series is because it has plus symbols in between and stuff. If it has like plus and minus symbols in between the terms, then you can refer to that as a series. So here it says, given this series, right, 2n terms is equal to your, oh, okay, so this series, right, you're adding values going on and on. So if you add a certain number of terms, they add up to 72,710. They say it here, calculate the number of terms in the series. So this may seem like a difficult question, but it's actually quite simple, because they say given this 2n terms is equal to 20. I keep saying 20, it's 72. Given this 2n terms is 72,710. Calculate the number of terms in the series. So the one thing is, we can see here they're adding 3 plus 3 plus 3. So we can see that our common difference is just 3. So here it's an Sn formula question. You know, it's just the Sn formula here. Sn is equal to n over 2, 2a plus n minus 1d. And then our value for n is what we're looking for, but Sn is equal to 72,710. D, I mean, clearly it's just equal to 3, a is equal to 2. This question is just quite simple, but our marks are going to come from having to simplify and isolate n. So here Sn, where Sn is, we know that's just 72,710. N is what we're looking for, and then a is equal to 2. plus n minus 1, d is equal to 3. So we said your 5 marks here are coming from you being able to properly isolate n. So here 3 times n plus 3n minus 3. And then 72,710, let's see here, this is going to be n over 2. 4 minus 3, that's just a 1. So it's like 3n plus 1 if you want. 72,000 and whatnot there. So here you can multiply inside if you want. It's just going to be 3n squared over 2. And then this is going to be n over 2. Which is just, excuse me, this is like 72,710. I feel like this seems like a long dry, but you see your two terms have the same term, or the same denominator, sorry. So your two terms have the same denominator, so you know that you can basically just write them out on top together. And then multiply by 2 on both sides. This we have like 3n squared plus n. Whew, yeah, this might as well just look at that in the calculator. Let's see here, 72,710 times 2. Well, yeah, it's going to be 145,420. Yeah, 145,420. And then because we're solving for n, I mean, clearly it's best to take everything to the one side. And then here it is going to, yeah, I mean the quadratic formula once. So n is going to be equal to minus b to the positive 1 plus minus b squared minus 4ac. Yeah, this is quite a big number, but I mean that's what we're getting, right? So you use it. You know, don't be intimidated by big values in your exams. If they're big, they're big. It's not your fault. So all this in the calculator, you're going to get that your value for n is equal to 220, or your value for n is equal to, well, your value for n cannot be a negative, so you'll need to disregard this second value because n cannot be a negative. And before writing this out, you could have also written out the formula, minus b plus minus b squared minus 4ac over 2a, so that you are like 100%, you know, okay with what you're writing down. So this is your value for n. So the sum of the first 220 terms is what's going to give you this value there. So I think this question was also quite straightforward, was not so bad. And now we just need to move on to question number 4. So question 4 says the sum of the first two terms, okay, the sum of the first two terms of a geometric series with positive terms, the sum of the first two terms of a geometric series with positive terms where r is not equal to negative 1 is 4 times the sum of the next two terms. The sum to infinity of this series is 3. Show that r is equal to a half. So here obviously I want to read it again. The sum of the first two terms of a geometric series. So with a geometric series, always be able to visualize it as this. You see, your geometric series always has a, and then ar to the power of 2, ar to the power of 3, going on and on and on until ar to the power of n. This is what you want to visualize a geometric sequence as. If it's a series, then this is probably just like a plus or a minus, plus or minus, plus or minus, going on and on and on, or whichever way you want to think of it. So with this series, right, they said it has two terms. The first two terms of a geometric series with positive terms, yes, where r is not equal to negative 1 is 4. So the sum of the first two terms. So basically that means a, the first term, right, plus the second term. You see, because this is t1, this is t2. The sum of the first two terms, they said it is equal to 4. So see, term 1 plus term 2 gives you 4. Okay, that's an equation. And then they said here that, what else did they say here? They said is 4. Wow, I'm getting ahead of myself. They said the sum of the first two terms of a geometric series which has positive terms is 4 times the sum of the next two terms. So it is 4 times the sum of the next two terms. So the next two terms would be these two here, which is this and that. So AR cubed. Whew. Yeah, let's read that again. The sum of the first two terms of a geometric series. The sum of the first two terms of a geometric series is 4 times. It is 4 times the sum of the next two terms, you see. So the first two, and then these are the first two, these are the next two. This is actually supposed to be a plus. So the first two times 4 times the next two terms. This is our equation. They said here, furthermore, that the sum to infinity is 3. So our sum to infinity is going to be equal to 3, meaning if you think of our sum to infinity come on, dude. If you think of our sum to infinity formula, this is technically what they've given us. You see, we have two equations here that both have a and r. So our task is to just simplify and solve for a and r, because they said here we should show that r is equal to a half for 4 marks. So if you're going to show that r is equal to a half, we just need to simplify these two and technically solve them simultaneously. That's the only thing that looks like it makes sense here. So let's simplify this here quickly. And then just looking at this, yeah, it doesn't look friendly at all, but let's take everything to one side. Maybe it will look better. So this is 0 is equal to 4ar cubed plus 4ar squared minus ar minus a. So the good news is, I mean, looking at what we're given here, it looks like we can simplify a variable. Let's see which one is the easiest one to isolate. I would not isolate a value for r, because I mean, if you were to throw r in here, you'd put r there, and it's just a mess. So it looks like, let's isolate a. Yeah, if you isolate a here, it's going to be 3 1 minus r, that's equal to a. This is like 3 minus 3r, that's a. Sure, yeah, let's throw that where a is, see what we end up with. If it becomes too much, we'll just try and see if there's an easier way. 4, and then we throw in here 3 minus 3r, and then here we have r cubed plus let's see what the next one is. The next one is practically, what is the next one? Well, just looking at the way this is, right? Yeah, let's just carry on. Why be funny? So we threw a there, and then here we just need to throw a in there again. So this is going to be 3 minus 3r with r squared, and then this is going to be 3 minus 3r in brackets, and then this is minus 3r. Yeah, I hope you're thinking what I'm thinking. This is just too many things to write out. So yeah, let's scrape this out. Let's go back to this easier one. So let's see here. If you throw a and a there, well, I mean, a is a common factor in all of them. So let's just take a out as a common factor. Like you see, a goes out here, we're going to have 1 minus r. If a goes out here, you're going to have a and then 4r squared plus 4r cubed. And then, I mean, look, we don't even have to do anything. We can just simplify here by removing a, actually. Yeah, so in an exam, always be ready to pivot. If something looks like it's just going to be a mess, stop it. You know, just try something else. So here, solving for r, we're ending up, it looks like we're ending up with a trinomial. I mean, like one way or the other. But even before that, let's see, here we can take out r, 4r squared as a common factor. This is going to be like 1 minus r, and then here we have 1 minus r. Ooh, whoa, fancy. So this, it looks like 1 minus r can be removed from both sides, and then we have 1 is equal to 4r squared. And then dividing by 4 on both sides, we technically have r squared is a quarter, which is clearly, if you square root both sides, you're going to have square root of 1 at the top over square root of 4 at the bottom. which is just 1 over 2. And that's exactly what they wanted us to show. You see, they said here we should show that r is equal to a half. And we've done that. We were about to overcomplicate it, but remember, always be ready to change your mind, because why not? You know. So that's how we did 3 point, no, it's question 4, 4.1. So 4.1, that's all we had to do. 4.2 says, unless maybe you want to see it a bit more, I don't know, maybe not, you could pause, I guess, but here we are. The next one says for 2 marks only, okay, calculate the value of the first term. Wow, they literally just want us to get a value for a, which is quite dumb, because we have our SN formula here. Let's just put here 4.2. So our sum to infinity, they said, we know it's this formula, right? And they told us that our sum to infinity is equal to 3. And we have a value for r, you see. So this is just a over a half, and then this is 3. A half times 3, I mean, that's just 3 over 2, and then that's your value for a. It's quite straightforward, nothing much to it. So you just move on to the next question, which is question number 5. Okay, so question number 5 in this KwaZulu-Natal 2020 prelim exam, paper 1. Yeah, in the mathematics prelim paper from 2020 September. Here we go, question 5. It's a functions question. So here we're clearly given a looks like we're given a hyperbola. Yep, it doesn't look like it, it is it. So here it says write down the asymptotes of the vertical and write down the equations of the vertical and horizontal asymptotes of g. So the one thing to look out for is, you see how this is, it looks quite strange, and I understand if this is, it definitely just does look strange. However, it's okay. It's not like a weird question or anything like that. We would not want to overthink anything. So just looking at our equation, we clearly can see that our 2 asymptotes are always given by these 2 values, you see, because the equation, the standard form of a parabola looks like this: x minus p plus q. You see, this, the opposite, will give you the equation of your vertical asymptote. Remember, vertical is from top to bottom. You see, this is vertical, and then horizontal is from left to right, horizontal, just in case you're wondering. So here, our one equation, we need to say that x is equal to the opposite of this value, so x is equal to -3, and then the horizontal asymptote, we're going to need to say y is equal to -1. This one we take it as it is, this one we take the opposite if you're giving asymptotes, because with asymptotes, looking at your hyperbola, you always look at these 2 values. For the x asymptote, you take the opposite of this value. For the y asymptote, the equation of that, you take this value as it is. You see, as long as it's already in this format, the top is just a value a. It's not a 9, it's an a. So that's for 5.1. It's straightforward, nothing much to it. Let's see what the next question wants us to do. They say it here, determine the intercepts of the graph of f with the axes. So we need to get the intercepts of this graph. So technically we need to get the x-intercept and the y-intercept. So the x-intercept, I mean, you need to make y equal to 0. And you see, this represents y. So this is a 0, 1 over 2x plus 3 minus 1. Solving for x here, the 1 is going to go over, becomes a positive, and then we have 2x plus 6 in there. You can multiply by 2x plus 6 on both sides. This is going to be 2x plus 6. And then here you're going to have a 1. If you move everything to the one side, you're going to have 2x plus 6 minus 1, which is like 2x plus 5. I'm moving it back, which is weird. But anyways, divide by 2 on both sides. So our x-intercept is going to be -5 over 2. And then for our y-intercept, let's put here y-intercept, you need to make x equal to 0. So in our equation, getting our value for our y-intercept, we need to make x equal to 0. So if that's a 0 here, technically you just have 1 over 2 with the 3 there, and then we have 1 over 6 minus 1, which is like negative 5 over 6 there, which is okay. So the only thing is, you see here they said we should determine the intercept of the graph of g with the axis. So we know this is the x-intercept. So our x value is this, but then our y value is 0. And then here we know that our y value is this, but our x value is 0. So always try and leave your answers as coordinates. Not try, just do it, Nike. So these are our two values. They'll give us 3 marks for that. And this was 5.2. Yep. And yeah, you can see, today we're moving like blazing. 5.3 says draw the graph of G, show all intercepts with the axis as well as the asymptotes for 4 marks. So that's like a simple question. You're thinking of what we have just done, and so for 5.3 it's quite straightforward, meaning you just want to put your asymptotes first, which is -3 and -1. So you see here, I'm not even using a scale. You see, I'm just putting things, just thinking of ways that they would fit. You see, because that's your x-axis, this is a y-axis. So the equation x is equal to -3 has to be a line going straight downwards, cutting -3. Y is equal to -3 has to be a horizontal line cutting -1. You see here I've labeled -1, and here, if that's not clear, let's just put -3 there. I don't think it's a big deal. So our two asymptotes. Now our intercepts, we know that this is a value for x. Remember, this is a value for y. So -5 over 2, that's like -2.5. So that's like somewhere here. There we go. That's an intercept. And then you can even label it. That's gonna be, let's just focus here. This is gonna be -5 over 2 with the 0 there. And then this one, we can see it's -5 over 6. If you can just check what the decimal value is in your calculator. That's like -0.8. So -0.8. So remember, this is x, this is y. So -0.8, that's like somewhere there. Hey, that's just odd. But anyways, the good news is with all hyperbolas, you see, if you have your asymptotes, if your a value is a plus, then your asymptotes your curves go here and there. If your a value is a negative, then your curves go there and there. And all this, you can find it in the playlist for functions and graphs. So our a value here is clearly a positive number. So you see, you're going to have a curve over here. So this is, let's just draw a curve there. You see, I'm not even doing, hey, this is not a very nice looking curve, pun intended, my bad. But anyways, this is just, let's just draw this, finesse it quickly. Yeah, that looks fine. And then obviously, because our asymptote is here, our other curve, you just draw it. You see, there's no point here to show, so you can just draw it, because we've shown our asymptotes, we've shown our intercepts, and you've shown the curve. You can even label it g of x now. There you go. You're gonna get your 4 marks here. You're not gonna get penalized for anything, because this is all that they want you to do for this question. And we're moving, guys. I'm loving it. Da 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 da. So let's move on to question number 8 now. So I don't know why I said question number 8, whereas it's actually question number 6. But with question number 6, we have a graph here. And this question, they said here the diagram of the graphs of f and g, they have these two equations. They are drawn below. F and g intersect at c and d. And then they said here a is the y-intercept of f, and P and Q are any points on the graph of f and g. So P and Q can be anywhere. You see, P can be anywhere there, Q can be anywhere there. And then they said here, yeah, there can be any points on these two graphs respectively where PQ is parallel to the PQ is parallel to the y-axis. So what they mean is as P moves to the left or to the right, Q will also be moving to the left or to the right, so that this line remains parallel to the y-axis, so they move together. All this being given, they said here, write down the coordinates of A for 1 mark. Okay, thank you. For A, we know that's just the y-intercept of F, and the y-intercept of F is just a positive 2. So if you're going to write down the coordinates of A, that's a given mark. So like 6.1, our A value, clearly because it's it's a y-intercept, the x value is a 0. And according to our equation, there's our equation, it's a positive 2. So the y-intercept there is a positive 2. So that's A. Hey, I want to see there. Quick, straightforward, moving on. Nothing to worry about. Yeah, this camera's moving. Calculate the coordinates of C and D. So C and D are the points where the two graphs meet. That's just straightforward. It's just a matter of equating the two equations together. So we need to write down the equation of G and the equation of F, you see. So where two graphs meet, it is basically going to be, yeah, where C and D, we said it's where the two graphs meet. So we have to equate the two equations and then just simplify. So equation of f of x, we have there, it's a quadratic equation, and that quadratic equation, we need to equate it to the second quadratic equation. So here, this quadratic equation for f, we need to make it equal to the quadratic equation of g. Let's just write it out nicely here, minus x, and then dig in. Sure, dig in. So I think it's best if we take everything to the right, because it's best if this value here is a positive number. Minus x, minus 2. You see, took everything over. Yeah, you see, this took it over, it became a minus. This took it over, it became a plus. So here technically we have like 3 over 2x squared minus 2x minus 2. And then, I mean, this is clearly going to be the quadratic, it's going to be a quadratic equation. And with this quadratic equation, you can just put it into your quadratic formula. There's nothing to worry about here. X equal to minus b plus minus b squared minus 4ac over 2a. Even though they are fractions, so you don't have to do any funny business. Minus b plus minus, I don't even write on lines. b is minus 2 squared minus 4. Our a value is 3 over 2. Our c value is negative 2. Yee, this looks terrible. Our a value is 3 over 2. So let's just put this in the calculator actually. Fraction button. And then what do we have to put there? Yeah, fraction button. Well, fraction button. Negative 2. And then, let's just do it like that. And then we have a plus first, and then square root symbol. Negative 2 squared minus 4a, and then our value for c is like negative 2, and then our value for a is 3 over 2. Whew, yeah, this is not so good. But let's see. X is a positive 2. Okay, x is equal to 2, or in our calculator, our other x value, if you put a minus there, is going to be negative 3 over 2. Negative 2 over 3, sorry. Yeah, those are our two x values. And fortunately, to get our values for y, we can throw it into any of our original equations, you see, because clearly the negative values for c, the positive values for d. I mean, clearly d is going to be a 2, the x value is going to be a 2 there, the y value is going to be a 0. So for d, we can already give a value 2, coordinate 0. The reason is this is, you see, an x-intercept, so the y value is a 0 automatically. So I mean, whichever way, for the other y value, you can throw this value into any of your equations. Let's throw it into that one. Let's see here. So this is going to be y is equal to a half negative 2 over 3 squared. minus x, right? So we're minusing negative 2 over 3 again. And then all this into your calculator. Let's see here, half. And then you have negative 2 over 3 squared minus negative 2 over 3. Okay, that's like 8 over 9. That's fine. 8 over 9. So you can then say, therefore, that's for C now. C is going to be negative 2 over 3 and 8 over 9. How many marks? They say they're going to give us 5 marks. So this is okay for 5 marks. Nothing fishy. Take your marks and you move on. So determine the values. Hey, why is so blurry? Determine the values of x for which this reminds me of the latest playlist, or one of the latest playlists, which is Inequalities. So here they say determine the values of x for which f of x is smaller or equal to g of x. So okay, so questions like these, basically all they're asking you is, you have y values of f, right? Where are the y values of f smaller or equal to the y values of g? That's what this question is asking. So you want to compare your two graphs, looking at, this is f, and then this is g. So you want to focus more on where they meet. So here, this is equal to each other. These are equal to each other here at this x value and at this x value. So here they want you to give the x values where the y values of f are below or equal to the y values of g. So if you look at where f is, you see here, these y values of g, they are going down, 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 down. These y values of f are going down, right? And then these y values of f are also going down. You see, these y values of f are lower than the y values of g. You see, because g is going up. From here, technically g has y values that are bigger than the y values of f. And then from here towards the left, g has y values that are bigger than the graph of f. You see, that's what they want us to show. The portions where f has y values that are smaller than the graph of g, you see. It's only from here going to the left, from here going to the left. Because in between here, this scenario is not occurring. Because here you see, f has y values that are bigger than the graph of g. So this is not what they want us to show or to give as an answer. Our answer needs to say that our x values need to be starting from this x value going to the left, and then our x values need to be starting from this x value going to the right. So as an answer for 6.3, we basically need to say that our x values need to be smaller or equal to negative 2 over 3, or our x values need to be bigger or equal to positive 2. You could have even said that x is an element of, let's see here. Well, technically x is an element of negative infinity until negative 2 over 3, or x is an element of positive 2 until infinity. You see, this is also what you could have written down as your answer. It's a choice. You could have also said x needs to be bigger, or x needs to be smaller. X needs to be smaller or equal to negative 2 over 3, and x needs to be bigger or equal to positive 2, like that, because that's what this represents. You see, you can write it as that, you can write it as this, and you can write it as this down here, you see, because x needs to be smaller than negative 2 over 3. X needs to be smaller or equal to negative 2 over 3, or x needs to be bigger or equal to 2. That's just a 2-mark question. And again, there are many more examples in the playlist. If you check in the playlists, right, you have like different tutorials, ones from like the other channel, which is dope. So the next one says calculate the maximum length of PQ, where PQ is a line between C and D. So this is a common question. It's actually quite simple. If you're not familiar with this question, you need to go through more past papers. I'm sorry, but it is what it is. So getting the maximum length of PQ, all you want to remember is P is representing y values of p is being represented by f. Let's just look at it that way. Q is being represented by G. So whenever you need to get the length of a line between two graphs, all you need to do is you need to look for the graph on top minus the graph at the bottom. So what I mean is, before we even worry about the maximum length of PQ, what we need is an equation of the length of PQ, you see. So the equation of the length of PQ in terms of, so PQ, right, will be equal to the graph that's on top, which is F, minus the graph at the bottom. So this is going to give you the length of PQ, you see, in terms of x, of which all that boils down to is negative x squared plus x plus 2 minus a half x squared minus x. If you simplify this, you are getting here negative x squared plus x plus 2 minus a half squared plus x. Now with this, we can see here this is going to be negative, let's see, what is this? Negative 3 over 2 x squared, and then this plus that's going to give you 2x, and then this is just a positive 2. So this is going to give you the length of PQ in terms of x. So technically, if you want to get the maximum length, then just like all questions, you need to take this equation and you need to differentiate it and equate it to 0 to get an x value that will result in the maximum length. And let me just expand on this a bit. So what I mean is, this equation gives you length if you give it a specific x value. So if you want the maximum length, you need to get that specific x value by differentiating once and equating to 0. You find that x value. So once you've found that x value, you throw it back in here and you get your maximum length. So getting the max or the minimum of stuff, again, that's also in the applications of calculus playlist. So here, let's just differentiate our equation once. Differentiating it once is just 2 times this value, which is basically like negative 3x, and then 1 times 2, that's like positive 2. This, if you differentiate it, it's a constant, so it just falls away. So this differentiated just looks like this. If you equate it to 0, you know that it's going to be 3x there with a 2. Divide by 3 on both sides, our x is 2 over 3. So this value of x, we need to now throw it into our length equation. See, this gives us the length. This is the value that will result in the maximum length. So 2 over 3, we're going to throw it into the original one and see what the maximum length will be. 2 over 3 squared plus 2 over 3 plus 2. Now, if you throw all this into your calculator, you should get the 8 over 3, which is equal to 2.67 units. So that's quite straightforward. Again, longer tutorials on like different stuff are in the playlists, because the playlists are linked between the two channels. So that's for 6.4. 6.4, it's a common question. This is what you need to do whenever you need to get the length between 2 points on the same line, but on 2 different graphs. So for 3 marks, the next question says, calculate the value of x where the gradient of f is equal to 3. Sure, this paper had such nice questions. So we need to get the gradient of f. We need to get the x value where the gradient of f is equal to 3. So all we need is the gradient equation of f. So to start off, I mean, we have the original equation of f. What is the original equation of f? Because we just need to differentiate it to find its gradient equation. So the original equation is like negative x squared plus x plus 2. So this equation, to find the x value where the gradient is a 3, we need to find the gradient equation first. So our gradient equation here is just differentiating once. We have our gradient equation. Now we know that they said we should find the x value where the gradient is at 3. So the gradient, we make that at 3. And then here we can take the 2x over so that it becomes a positive, and then the 3 we can throw that side. And then here technically x is going to be equal to negative a half. So that's a straightforward question, but let's see here. Did I do this correctly? Let me just double check here, because something looks a bit off. Oh yes. Where did I get this? My bad. 2 seconds. Hold on. So differentiating this, it is just negative 2x plus 1, because this is a constant. It falls away. So that differentiating this is just 1 times 1, which is just a 1. So here, if you equate this to 3, we're going to get here, let's actually just leave that there, 3 minus 1, and then this is just a 2. Divide both sides by negative 2, we're getting here our x value to be equal to negative 1. Yeah, so always double check your stuff, because you never know when, something will strike. So there we go for that question. Now we just need to move on to 6.6. 6.6 for 4 marks says determine the values of k for which f of x is equal to k has 2 positive unequal roots. So this is one of those kind nature of roots questions, and yeah, I'm going to make a nature of roots playlist soon, so stay tuned for that. So here we need to work out where f of x is equal to k has 2 positive unequal roots. So where is f of x equal to k having 2 unequal positive roots? So all we need to do is we need to equate f of x to k and simplify. So f of x, we said it is this equation up there, negative x squared plus x plus 2 is equal to k. Now if you what you want to do is, for questions like these, always try and put your equation in standard form first, so that all you need to do now is, if you're going to look for where you have 2 positive unequal roots, so we need the roots that are unequal. So where roots are unequal, you need to work out where delta is going to be bigger than 0. Yeah, 2 unequal roots. We need to work out where delta is bigger than 0. Now delta is this value here, minus b minus 4ac. So we need to work out where is this bigger than 0. Okay, so here firstly our a value here is technically negative 1, our b value is a positive 1, our c value is this whole thing here, 2 minus k. So we need to work out where b squared minus 4ac is bigger than 0. So b squared minus 4ac, where is it bigger than 0? So here this is like 1. Let's see, this is going to be a positive 4, 2 minus k. And then this is like 1 plus 8 minus 4k, bigger than 0. And then this here, the 4k can go over, it becomes a positive. And remember, we're not dividing by a negative, so it stays, nothing flips over. And then here you just have 9. And then technically, the funny thing is, with this question, right, here we're getting that our value for k, let's see there, what is 9? Here we're going to get k here with a negative, with a 4 there, So we need to analyze this question some more before just leaving it like this, you see, because if you just leave it like this, you may not like your paper when it comes back. So what we have here, we need to analyze it. So when they said so let's just put this is going to be 9 over 4, which is technically just 2 1/4. So the big issue is, they said this is part of your answer. K needs to be smaller than 2 1/4. Whoa. What did I just do here? Yeah, k is smaller than 2 1/4. Yeah, it just looks a bit weird like that. So the key thing here, they said they want us to get values for k for which this has two positive unequal roots. So this will give us unequal roots. However, we need to take into account where our equation here is going to result in us having two positive roots. So what that means is, firstly, if you check our equation of f, k, if you look at where k is, if you see here where k is, we move k over. K has an effect of moving the graph of f down. You see, we're minusing a value here. So here, whatever k is, we basically need to work out how many units downwards can we move our graph until it has two positive roots that are not equal to each other. So if you think of it, firstly, this value here is equal to positive 2, right? Our a value is a positive 2. Now, if you move your graph 2 units downwards, a minimum of 2 units downwards, it's going to look something like this. Like this value is going to be there, and then your graph is going to look something like this. Let's just put this hypothetically. So here you see your graph will have an x-intercept there and an x-intercept there if it is moved a minimum of 2 units downwards. You see, if you move it at minimum of 2 units downwards, it will start having roots that are positive, you see, and that are not equal to each other. And then this is telling us that the maximum number of units that you can move it downwards is going to be 2.25 units. So if you keep moving it downwards, eventually your graph will, you see, look something like that, meaning that the distance from here going all the way to your x-axis, this is technically going to be 2.25. So yeah, this is one of those questions which I'm assuming you may end up skipping in an exam because it's not the nicest one to understand and whatnot. But basically all we're going to have to say here is our graph, looking at what k does, k basically moves our graph downwards. So here, to give our answer fully, we basically need to say that our graph can be moved down a minimum of 2 units and a maximum of 2.25 units. So meaning the answer here, we need to say that k needs to be, technically k needs to be bigger than k. What does k need to be bigger than? K would need to be bigger than 2 and k would need to be smaller than 2.25. See, because here this is saying k needs to be smaller than 2.25. And then, just looking at our sketch, we know that the minimum number of units that it can be moved downwards to satisfy this question is just going to be 2 units. I think this is one of those questions that may not be the best to listen to right now. It's just nonsense. But anyways, determine the values of k for which f of x is equal to k has 2 positive unequal roots. So for this graph to have 2 roots that are positive, it has to be moved down a minimum of 2 units. Because you see this value is a 2, so if you move it 2 down, it will start having 2 positive roots. Now if you keep moving it downwards, it will eventually only have 1 root. So to keep it having 2 roots that are unequal, you can only move it between 2 units and 2.25 units. So that's just for 4 marks. And again, you're going to have a nature of roots playlist soon to go through more examples like this. So for 6.6, you'll need to say k is technically smaller than 2.25 and k needs to be bigger than 2. If you write it like this, that's fine. If you wrote it like that, that's also still fine. It is both saying the same thing. So yeah, nature of roots questions, they are what they are. So question number 7 in this 2020 September prelim paper from KwaZulu-Natal for maths paper 1, this is what we have. They said in the diagram the graph of g of x is equal to this. So this is clearly the inverse of an exponential graph. They like giving us questions like this. So we have the inverse of an exponential graph. So automatically what we know is we have the inverse line here somewhere, and our original graph technically would have looked something like let's just finesse this quickly, something like that. Yep. So this is g, so technically its inverse is going to look like that. because yeah, the theory, boys and girls, you need to know your theory. And then yeah, so anyways, this being given, they said here write down the equation of the inverse of g in the form y for 2 marks. So yeah, this is not too uncommon, it's quite common really. So for 7.1, the one big issue is they've given us this equation here. G of x is equal to log 3x. If you've gone through any of the previous papers, then you probably know what to do here, because all that's happening here is, you see, this is y and then this is x. So for inverse, you have to swap x and y. X becomes y, y becomes x, meaning this is now x and then this is now y. So the idea now is you need to isolate y. That's what inverse says. You need to swap the two and isolate y. Isolating y here, we just need to remember that this is the base, this is the exponent. You see, you have a base here, you have an exponent there. You see, so if this is the base and this is the exponent, you just end up with obviously 3 as the base, x as the exponent, and then y is on its own. Voila. See, that's it. You have gotten the inverse in terms of y, because you swap x and y and then you just simplify, because this is a base, sorry, this is a base, this is an exponent. The base of your log is always the base of your exponent, you see. So that's for 7.1. For 7.2, they said write down the range of the inverse. You see, with a picture it makes things so much easier. That's why this is a 1 mark question. The range, we can clearly see the graph is from here going up, you see. Range, remember, you have to look at the y values. So our y values are all bigger than 0, you see, but they will never touch 0. So the range here, 7.2, we just need to say that y is bigger than 0. The reason why we're saying bigger than 0 and not bigger or equal to 0 is because, I mean, look at the equation of our inverse. You see, the asymptote here is a 0, so the y value will never touch a 0, because all exponential graphs are somewhat in this format, you see. This will always give you asymptote. And again, if you want to go through all that and all the theory, that's in the playlists. If you go on the playlists tab, you will see the playlists. There are many. So here the next one says calculate the values of x for which this whole thing is occurring. So to just make this a bit simpler, all you want to do is to write down whatever this expression will be. So it's 2, and then you're multiplying by the graph of g, and you're working out where that is smaller than -6 for 4 marks. Okay, so our graph of g, I mean, it's a log equation. It's 2, and then you have log 3x. Where is that smaller or equal to -6? So the big issue is here you may be thinking to yourself, whoa, what do we do now? Well, here let's try and simplify. Let's divide both sides by 2. Let's see what we end up with. You're going to end up with log 3x. Where is it smaller or equal to -3? Okay, so that's what this question is asking us. If you look at it clearly now, it doesn't seem bad at all. It's just straightforward now. They're asking us, where's the graph of g? Where is it? You see, this is the equation of g, and this is what we're seeing here. You see, so technically our question could have even easily have been given like this. You see, where is the graph of g smaller or equal to -3? So whenever they ask questions like these, this represents y, you see. So this is technically asking, where are the y values of g smaller or equal to -3? So technically we need to find out where they are equal to -3. Say somewhere here the y value is -3. We need to find out what this x value is. See, calculate the x values for which this is occurring. We said this question is just asking us, where is the graph of g smaller or equal to 3? So we know the graph of g is smaller or equal to 3, starting smaller or equal to -3, starting from wherever -3 is, going downwards. You see, so those x values will be from this x value until 0. You see, where 0 is not included. So to answer this question, all we need to do is find out where the graph is equal to -3 to begin with. So to do that, let's just work out where is our graph equal to -3 first. And we said here this will always just be your base, this will be your exponent. You see, base exponent. So base is 3, exponent is -3. This value will just be on its own. So here, 3 to the power of -3, that's just, 1 to the power of 3 to the power of 3. You can just throw all this in your calculator, it's not a problem. So x is 1/27. Okay, that's interesting, you see, because we said we want the x value where this y value is occurring. So this x value is just 1/27. So we know that the graph, this is happening. You see, the question started off like that, but we simplified it to this. So this is happening where your x values are clearly smaller than this value and your x values are bigger than 0. So that's what you can say. X needs to be smaller or equal to that, or x needs to be bigger than 0. You see, we're saying x needs to be bigger than 0 because it will never touch 0, you see. It will always be bigger than 0. And then x, here we said it is smaller or equal to 1/27 because, you see, at 1/27 it is equal to -3, which is what we have there. So it's all linking up because, you see, this is not what we need to focus on. We need to focus on what we have here, which is the simplified version of the question. So here, that's what we had to say. Calculate the values of x for which this is happening. We say this is basically asking where is the graph of g smaller or equal to 3. And again, with inequalities, if they are not your friend, go to this playlist, Inequalities grade 12. There's like a ton of examples there to go through this stuff. So that's for question 7.3. Now we're going to work on question number 8. Question number 8 is financial maths, as it seems. It says here, an investor indicates that he will, what will he do? An investor indicates that he will be able to treble. So this means triple. Yeah, in case you're wondering, triple. Make things simple, guys. Why are you putting funny words? An investor indicates that he will be able to treble the value of the investment at the end of 6 years. The interest rate is fixed and compounded monthly. Calculate the annual interest rate that the investor has on offer. So questions like these are quite simple because the first thing is, let's put these next to each other. And put that there. And put that there. There. So question, yeah, this is the IG page for my examples and stuff like that. But anyways, let's see here. Question 8.1, right? The one thing is, this investor has some money, right? This is his initial investment. At the end of the day, he's going to get triple that. The interest rate, we don't know. But then he says he can triple it in 6 years. The only issue is this money is compounded monthly. So this n has to be multiplied by 12. And then this I has to be divided by 12. Okay, this is what we have. It's very nice and simple. So yeah, let me try and not make this funny. Let's just say I is a value over 12. You see, this is our interest. Let's put here interest. I'm going to point here interest. Interest. Why am I making this seem so complicated? So yeah, it's actually not. But anyways, you see here, we're thinking to ourselves, this guy is not going to make any monthly installments or anything like that. He's just investing some money. He says he's going to triple it in 6 years with a fixed compound interest rate. And then this is going to be for 6 years. They're asking us how much is his interest. So there are no monthly installments. So it's just going to be our normal A formula. A1 plus I to the power of n. Now we said A is just 3 times whatever the investment was. And then 1 plus our interest, which is going to be over 12. N is going to be 6 times 12, which is like 36. No, that does not look right at all. 6 times 12 is 72, boss. It's double. 72. So here, the lucky thing is, you see, the reason why I say this is common is because here we're just going to divide by x. This goes away. This is like 3 is equal to 1 plus I over 12. And then because this is to the power of 72, you can put a square root symbol with 72 here, surd with 72 there. This will cancel that. And then 1 plus I over 12. Then this here, you can just put that in your calculator, you see. Like put the surd symbol or shift surd. And then throw a 72 there, and then throw your 3 there. Boom. Ooh, yeah. Let's just use this the way it is. 72 square root of 3. Let's not simplify. So here the 1 goes over. 72 square root of 3 minus 1. I over 12. And then you can multiply by 12 on both sides clearly. Times 12. Times 12. This is going to be 12 times 72. And then this, you can put the whole thing in your calculator. Let's see what it gives us. So let's see here. 12. Shift this. 72. And 3 there minus 1. So remember, this value we have to multiply by 100 because we're working with percentages. So here our I is going to be times 100, this value, 18.45%. 18.45%. You see, so that's going to be our value for I there. Because you see, what we had before, it's just, you know, this is not our percentage. You see, remember, because remember in a calculator you would have divided by 100. So whenever you get a value for I, whatever your final answer is, never forget to times by 100. So that's our interest. Yeah, these questions are quite common, and again, the more past papers you do, the more questions like these you run into, and yeah, they should not be funny. The next one says, Samuel decided to buy a car costing $192,000. He takes out a loan for 5 years at an interest rate of this much, compounded monthly. Payments are made at the end of each month. Then they said calculate the monthly repayments over the 5-year period. Very straightforward question. Wow. Okay, no jokes. This paper was like super easy. Like, wow, these guys had it nice. Yo, so this is P. Oh snap. P is going to be equal to, we know that our P formula says x 1 minus 1 plus I to the power of negative n. The whole thing over I. Yep. Because of our formula sheet, which you should never forget. And then, so here our x value, that's what they wanted. That's what they want us to work out. So it's easier to isolate x first. Interest, they said it is 12% per annum, compounded monthly. So it's going to be 12 over 100, and then times 12 down there, because you always take your interest divided by 12. So you can just, I always do it like this, because it's just your interest divided by 12. Yeah. And then n, they said for 5 years. Yeah, n is 5, times that by 12. And then P is the loan amount, which was 192,000. Okay, so let's see here. If you're going to work out x, it's easier to isolate x first. Meaning here you can multiply by I, multiply by I. And then you have like Pi is equal to x 1 minus 1 plus I to the power of negative n. And then obviously if x is going to be on its own, it means you divide both sides by this big bracket here, which is going to be Pi over the whole thing, 1 minus 1 plus I to the power of negative n. Okay, so our x value, let's throw in everything. 192,000. Like that. Interest, let's see here. This is technically going to be 1 over 100. Yep. 1 over 100. And then down here we're gonna have 1 minus 1 plus 1 over 100 to the power of negative 5 times that's 60. So here our x value, if you throw all that into your calculator very nicely, you're gonna get 4,270.93. Yeah, this interest rate was madness. So with this being said, I think it was okay, I guess. That's our x value. The next thing is, they said, after Summer had made 45 payments, he decides to settle the balance of the loan, or the balance on the loan. Calculate the lump sum. Calculate the lump sum that he will need to pay off the loan after he has made 45 payments. So after he has made 45 payments, well, the issue is here we just need to work out the balance on the loan first, and then, yeah, it's just the balance on the loan question, this one. There's really not much to it. And again, on the other tutorial channel, there is a balance on the loan, tutorial there. So there are two ways to get the balance on the loan. So here, the good news is, yeah, you can again go through the playlist there and stuff. So here we know he has made 45 payments. So if you want to use this formula, balance is equal to x1 minus 1 plus I to the power of negative n over I. This looks exactly like your P formula. The only issue is here n is the number of payments left. Payments left. So here in our case, 16 total, you see from the previous question. So meaning the number of payments left is 15. Our x, we already know what the monthly installments are. It's 4,270.93. Our interest rate, we said it was 12% over 100. And then what are we looking for? We're looking for the balance, which is balance, Yaga. Balance, we don't know. So our balance is clearly going to be equal to our value for the installment, which is 4,270.93, and then 1 minus 1 plus 12% over 100. You see, I'm even writing it differently to show you that you can write it whichever way you want. So 12%, this is over, no, it's over 12. Oh my gosh. It's 12% over 12. I'm rushing. It's 12% over 12 because it's compounded monthly. So 12% over 12. My bad. Yammer, people. Yammer. So, yeah, this all, you can throw it into your calculator nicely. So here, 12% over 12. If you throw all this into your calculator, you're getting the 59,000 actually. 59,216.72. 421. So what else? That's it. That's the balance. This is the lump sum that he will need to pay for him to pay off his loan. So that's that. Moving on to bigger and brighter things. So question 9 is the next one we're going to do, because financial maths now is done. Yeah, more examples on the maths channel. The maths page, So question 9 has differentiation, and differentiation is always friendly in my opinion. So question 9, we have differentiation. They said we should determine this using first principles, given that ax squared minus bx. Determine this, which is determine the gradient equation from first principles, given that f of x is equal to this, where b is a constant. So b is a constant. Okay, for 5 marks. Oops. I'm sitting on a cushion. But anyways, 9.1 says we need to use first principles, right? So here our first principles formula, f of x with an apostrophe there, is equal to lim h goes to 0, and then x plus h minus f of x, the whole thing over h. So the one thing to take away from this question is they said f of x is that thing there. It looks interesting, I guess. X squared minus bx. So technically this is going to be x plus h, the whole thing squared, minus bx plus h. Interesting. Yeah, this is gonna be deep. The way that it looks, yeah, it looks as though things are going to be quite interesting. So let's just see how this turns out. and we obviously don't want to overthink anything. So we can simply just simplify this and then just work it out normally. We don't want to think that anything is off here. So here this is just going to be x plus h, and then x plus h again, and then this is going to be minus bx minus bh, and then this is like x squared plus 2xh plus h squared minus bx plus bh. Okay, that's nice. So all we want to do is we need to just throw all that into our main formula. So f prime is equal to lim h goes to 0, and we said that let's see, this thing here is equal to this whole thing here. So this is like x squared plus 2xh plus h squared minus bx plus bh, and then we're subtracting this thing here. And you see I put brackets there because that's like super important. I feel like I've added myself one extra step unnecessarily, but it's kind of important. So the big thing is, you see here, whatever is at the top, because of the bracket that we have there, technically you are going to end up with the stuff in your brackets here. You're going to minus x squared, and then you're going to add bx. So that's always something you need to look out for. And you see, that's why I literally had to write down this extra step to just show that, because all you need to remember is stuff are always going to cancel out. This cancels with that, this cancels with that. If you see that stuff are not canceling out, you have done something wrong. I'm sorry. So 2xh plus h squared plus bh, the whole thing over h. And clearly the good news is, I mean, everything has h in it, so you can take out h as a common factor at the top, and then you can take out h as a common factor at the bottom. Well, this is just one thing, so this h cancels that h. And then here you just have lim. Woo! Why am I rushing? I don't know, but it seems like the right thing to do right now. So there we go. And then here, because you're done, you can just throw 0 where h is, and then this is your final answer. See? Pretty straightforward. Nothing major, nothing fancy. It's just what it is, you know, because this is all you have at the end. Because your original one, if you had just differentiated it using normal differentiation, you see 2 times x is just 2x. Ah, why did I put a plus there? Uh-oh. Where did the plus come from? No. No, why have I failed myself? Snap. Where did the plus come from? Yeah, I just need to check. Yeah, this is the mistake. This is just supposed to be a minus. You see, this is supposed to just be a minus. This would have been a minus. This would have been a minus. And then this would have been a minus. So this would have been a minus. And then this would have been a minus. You see, it's not a big deal. You don't get marked down for lack of neatness. So just double check your answers and fix whatever you need to fix. And then move on. You know, this is it. You will get all your marks for this. As messy as it may look, it's correct. Don't worry about it, you know, because what you're going to do, you can't t-pex it out anyway. So you have to do what you got to do. Don't scratch out everything and restart. No. Literally do what I just did. Go out and scratch all the pluses and replace them with minuses. It's perfectly fine. So now we just need to move on to the next question, which is for 3 marks. They want us to differentiate. So differentiating that for 3 marks, well, it's just normal differentiation. The big issue is, before we can differentiate, we always need to simplify. So when I say we always need to simplify, I mean, for example, we're given this thing here. It looks very funny. They have d over dx here. They just want us to differentiate. So before we can differentiate, we always want to simplify. Like here, this is just a quarter with x to the power 4. You see, like there's 1 over 4. So that's a quarter x to the power 4. And then here, you technically just have -3. And then this 3, you have a 1 here, right? So the 3 goes under the 1, which will leave you with x to the power of a third. And then that's just a 7. So that's what I mean by we need to simplify first before we work this out. And again, you can just check in the Calculus Grade 12 playlist to get all these methods. So here a quarter, x to the power 4. Here the 3 goes another 1, and then this is 7. So now we can differentiate. Because we are now differentiating, you can literally just put there, you don't have to be fancy or anything. It's literally just a matter of you saying equal to, and then you basically just what you do, you just carry on. You know, there's really not much to it. So here you're going to say equal to, and then you differentiate. This is just going to be 4 times a quarter, which is just 1, and then 4 minus 1, that's just 3. A third times a negative 3, that's going to give you a negative 1, and then a third minus 1, that's negative 2 over 3, and then 7 is a constant. So remember, anytime that you differentiate a constant, it just falls away anyways. So this is going to be a final answer. If you want to be fancy, you can just leave this with a positive exponent, which will be x. This whole thing goes under this number here, and then this will be a positive exponent. If you want to take that a step further, you could have the negative 1 over, you can take the 3 out, and then there you go. The only thing is this will have a 2 there. Don't remove the 2. Don't cancel out. Just leave it like that. This will be your final answer. This is perfectly fine. If they say don't leave it as a negative, if they say nothing about leaving your answers with positive exponents, this will also be perfect. You see, the other 2 down here, these are basically just optional. Yay, because why not show optional things? Yeah, so moving on, because that's for, what is this, 9.2. Yeah, 9.2. Moving on to bigger and 9.2.1 actually. Hey, yeah, so messy. Moving on to bigger and brighter things, like we said. 9.2.2 basically wants us to differentiate again. We need to get dy over dx. So the big issue is here, before you can get dy over dx, you have no choice but to simplify. And simplifying here, it's quite simple. We just need to multiply out the 2. We need to expand and multiply out. Like you see here, we have 1 bracket squared. So technically we're going to have 2 of these brackets, and then these 2 brackets, we need to multiply them by each other. This is an exponent. I should write better, bro. Like, write better. This times this, your bases are the same, so you add the exponents. A half plus a half, that's 1. This times this, I mean, same idea. Your bases are the same here, so you add your exponents, which is calculator work. You know, a half in your calculator, you need to add, what do you need to add there? A half in your calculator, you need to add, hey, just do it. A half, we need to add, because what are we doing here? This times this got us this. This times that, we need to add the exponents, which is a half plus 2 over 3, which is giving us 7 over 6. Hey, yeah, 7 over 6. So this and this, this and this, now this and this. So here now we can at least say 2x, and then 7 over 6 as well. And then plus here 4x. If your bases are the same, you add the exponents, so this is going to be 4 over 3. Whew. And then this is like x minus 4x 7 over 6 plus 4x to the power 4 over 3. Now the big issue is, you see, we need to differentiate afterwards, which is fine, because I mean, dy over dx is now going to be this. This is 1 times 1, which is just a 1. This times negative 4 in your calculator, that's just going to give you 14 over 3. Yep, that's going to give you 14 over 3. Negative 14 over 3. So this is going to be negative 14 over 3. I need to make sure I'm not making silly mistakes here, because I don't like making silly mistakes. Then this is x to the power of 1 over 6. And then this is plus, let's see here, 4 over 3 times 4. That's going to be 16 over 3 x. If you remove 1 from here, that's technically going to be a third. So that's just crazy. But where am I getting 14 here? Oh man, let me see here. I'm not feeling very good about this. Let me just double check this quickly. Ah, this is nonsense. I just realized, this is supposed to be a third. This is so unfair. This is supposed to be a third. Ah, man, so this is also going to be a third. My bad. I'm sorry. So this times that is going to give you x to the power of 2 over 3. And then this times that is going to give you negative 2x. And then this times that is going to give you another negative 2x. This times that is going to give you a positive 4 to the power of 4 over 3. Okay, this is going to be x 2 over 3 with negative 4x here, plus there's supposed to be x there, 4x, and then 4 over 3 as well. And then this, now we can differentiate it because we can. So this is equal to y, this is equal to y. So dy over dx is technically going to be 2 over 3x. Remove 1 from here, that's going to be a negative a third, which is fine. And then here, that's going to be negative 4. If you differentiate, this is still going to be 16 over 3x to the power of 1 over 3. And then that's it. They did not say anything about leaving your answers as positive exponents, so this will get you all your marks, all your 4 marks. And again, always be on the lookout for things that look funny, because like, why is this so weird? And then you see they had forgotten to write down a third. You see I wrote a half, which was probably you spotted it, but here we are moving on to the next question, which is question number 10. So question number 10. Question number 10. Here we go. They said here we have, well, this is clearly a parabola, but let's see. They have here, the first derivative of f is drawn. So this is the original equation, and then this is the first derivative that they've drawn. They said here the intercepts of the first derivative, or rather the f prime intersects the x-axis at negative 5 and at positive 1, and the y-axis at negative 15. Okay, that's interesting. So the key thing is, you see, if this is the equation of the first derivative, you want to remember that this is one turning point of the original graph. This is another turning point of the original graph. The reason is the y values of this graph gives you the gradients of the original graph. You see, this is f prime, so its y values give you the gradients of the original one. So you see here, if the y values are 0, it means that the gradient of the original graph is a 0 where x is a 5. If the y value here is a 0, it means that the gradient is a 0 where the x value is a negative 5. So if you need to go through more of that, you can go through the cubic functions playlist. There's a tutorial there on first derivatives and derivatives of graphs there. So here they said, write down the x values of the turning points of f. Wow, okay, I didn't even see that. But that's a 1 mark, that's a 2 mark question, as you can see. The 10.1, the x values, clearly x is going to be negative 5 or x is going to be equal to positive 1, like we said. The y values of this graph are giving you the gradients of the original one. So here the y value is a 0, so the gradient is a 0 where x is a 1. The y value is a 0 here, so the gradient is a 0 where x is a negative 5. 10.1.2 says x values where the gradient of f is equal to negative 15. So you see, this gives us gradients of the original one. So where the gradient is equal to negative 15, I mean the x value there is, well, technically there's 2 x values, you see, because I mean there's going to be an x value here, and then on the other side here there's going to be an x value there as well. So let's see what that x value is. So the x value here, I mean, is technically, what? The x value here is a 0. Yeah. You see, sure, right on the x values where the gradient is equal to negative 15. So 10.1 I did 10.1.1, right? 10.1.1, so 10.1.2, we know that the gradient is equal to 15 where x is a 0. So we need to find this other x value here. So to find that other x value, you may be thinking to yourself that we are going to do something funny or something complicated. And I mean, I hear you, it's okay. But remember, these two are symmetrical in the sense that you want to think logically. Like here, if this value here is at +1, you see, and this is at 0, it means that, you see, the distance between there and there is 1 unit. So meaning on the other side, if this is like a y-intercept and this is this value, because these are symmetrical, this also has to be 1 unit apart. That's literally how you're gonna finesse this question. If this is a -5, this is technically going to be a -4, you see, because if this is a 0, that's 1 unit until there, because they are symmetrical, you see. So if this, you can just use this as a reference, because from here to there, that's going to be 1 unit. So from here to there, that's also needs to be 1 unit. So this is 1 unit, so this is going to be a -4. Yep, yeah, math is, it is what it is. So here it says, show that the equation of f prime is given by this. So it's just getting the equation of this parabola. And we can use this formula, you see. Y is equal to, this is 10.2. So here we can say y is equal to a x minus x1, x minus x2, where these two are your intercepts. So if this is like a -5 and a 1, here you're gonna have +5 and -1. And then here, to get your value for a, you can just throw in a coordinate that the graph passes through. Now the good news is, you see, we have a coordinate that the graph passes through. This here is 0 coordinate 15. So y value is a 15, x value is a 0, and then here you have a, and then 5 times -1. The only issue is here you're going to get a negative a value, which is not what we want. So we have to pause and we have to investigate. So yeah, this is just crazy. So let's just pause here and think, oh, why is this not working out? Oh, no, it's perfect. It's -15. Whew, I was like, no, why are you doing this? So this is going to be a -5a, -15 divided by -5 on both sides. This is going to give you a is +3. So all you need to now do is you can just take this and you simplify it. So here you have y is equal to 3x plus 5 x minus 1. Let's FOIL this out. This is going to be 3 x times x is going to be x squared -x plus 5x minus 5. And then if you simplify inside, you have -1 plus 5, that's going to be a 4x. And then if you multiply that 3 inside, this is like 3x squared plus 12x minus 15. And then voila, I mean, look at what they wanted us to prove. That, you see, and we've proven it very simply. And what's that word? I don't know what the word is, but yeah, that was not very funny or strange or anything like that. You just have to remember this. And remember, we use something like this for cubic functions as well, where we have like a third one. But then for parabolas, you just have 2, and remember this value for a, and then you can throw in one intercept, another one as in the opposite values, and you can just simplify it, throw in a coordinate, and yeah, that's all we did. And they are going to give us how many marks? Let's see there. 3. Okay, moving on. The next one says, if this is a coordinate that the original graph passes through, calculate the value of d. Okay, so this is the equation, right? They want us to calculate the value of d. Sure. So we can just finesse this question. It's literally a question that we can just finesse. What I mean is, if you check this out, like this is 10.3, right? 10.3, what we want to remember is the original graph, right? Looks like this: ax cubed plus bx squared plus cx plus d. Now the big issue is if you differentiate this equation, it is going to be 3ax squared plus 2bx, and then plus c. Now we already know that the first derivative is this thing here, 3x squared plus 12x minus 15. So we can already see that just looking at this, if you match the two, you see there's x squared, there's x squared. So 3a is equal to 3, meaning a is equal to technically 1. And then here 2b is going to be equal to 12. 2b is equal to 12, so let's see here, this is b is equal to 6. And then here, c is equal to negative 15. It's not rocket science. We just mixed and matched. So from our original one, we already know that f of x, our a is a 1, so this is x cubed. Our b is a 6, so this is 6x squared. Our c is a negative 15, and then plus d. And the good news is they gave us a coordinate that the graph passes through. You see, x is negative 3 if y is a 0. So here, y we're going to make it a 0, where our x value is negative 3. So negative 3 squared plus 6 negative 3 squared minus 15 negative 3 plus d. And then here, if you work out your value for d and you simplify, you are getting a value of, let's see, 72. There you go. So 10.4 wants us to determine the coordinates of the turning points of f and state whether they are maximum or minimum turning points. So what we already know is that the x values of the turning points are negative 5 and positive 1. So the good news is, because we already have, or because now we have the equation of our graph. What is the equation of our graph? The equation of our graph is basically, well, technically, because d is equal to 72, our equation of our graph is, let's just write it down first, f of x, this is 10.4, f of x is going to be equal to, let's see here, x cubed plus 6x squared minus 15x plus 72. So the idea is we just need to throw in our 2x values in here, starting with what where is the paper? Where are you, paper? Yeah, starting with negative 5. So if you throw negative 5 in there, let's see here, 6 negative 5 squared negative 5 and then plus 72. So all this, we know that if you simplify, this is going to give you 28, and if your x value is negative 5, so this is a coordinate. If your x value is a positive 1, let's see here, 1 to the power of 3, throw a 1 there, 1, 72, all this in the calculator, this is going to give us negative 74 if our x values are 1. So we know we have two coordinates that are turning points. Now for you to be able to determine which one is a maximum turning point and which one is a minimum turning point, for this one, the one thing you want to remember is, firstly, you see here how we have a smiling parabola. You see, if you have a smiling parabola here as the equation of your first derivative, this smiling parabola means that we have a positive cubic graph. You see, so we have a maximum turning point here and a minimum turning point there. So if you just compare the two y values, we have positive 28 up there. So positive 28 would be a y value up here. Negative 74 would be a y value down there. It's quite simple to see here. So technically this one is going to be a maximum turning point. This one is going to be a minimum turning point. And you can just put that there like that and you move on. There's really no time to waste trying to have a moose here. So let's see here. 10.5 says this is given. Y is equal to tx plus 4 is a tangent to f. calculate the value of t. Well, the one thing we know is a tangent and a graph, wherever they meet, their gradients will always be the same. So with 10.5, it's a pretty straightforward question if you think of it. It's like 5 marks given away, because all we need to remember is we need to focus on the t. What we need to remember is the gradient of our tangent. We need to work out, firstly, the gradient of our tangent is a t. We need to work out where the gradient of our graph is equal to t. So you see, our gradient equation is this here, which is our first derivative. Now we need to work out where is this gradient equation equal to t. So you see here we end up with an equation that technically has x and t. So it is low-key telling us that we need to work out x and t simultaneously. So the other thing that you want to remember is a graph will always have the same coordinate as a graph will always have the same coordinate as a tangent at the point where they meet. So what we could do what you could do for yourself is, technically you could think to yourself, why don't we equate the two equations? So the only issue is equating the two equations is technically not going to happen. I mean, there's no ways we can equate the two equations, as in we can take the equation of the tangent here and equate it to the equation of f. That is just going to give you a big mess. So what you would actually want to do for a question like this one is you want to use, it's a strange method, if I can put it that way. It's definitely a strange method. However, what we know is this equation here, right? Technically, we are working out where the gradient is equal to a t. However, if you put this equation into standard form, let me put this into standard form. And the reason for us putting this equation into standard form is we basically want to work out a value for t where this equation has one solution. You see, we want to work out a value for t where the equation has one solution. Okay, so for this equation to have one solution, it's technically where delta is equal to 0, because we know that a tangent and a graph will only meet once. So we're basically working out a value for t where this whole equation has one solution. Yes, it's quite weird. But anyways, delta is b squared minus 4ac, where is it equal to 0. B, we know that it is equal to 12. We square that. A, we know it's equal to 3. C is technically equal to negative 15 minus t. Equate that to 0. And if you simplify here, you have 144 minus 12. Negative 15 minus t equal to 0. And then you have 144 here. This is going to be a plus, obviously. It's going to be positive 180 in your calculator. And this is going to be a plus 12t. And then here you have 12t. This is equal to... well, these are like terms. I mean, why did I not just... No, there's a plus. I was about to get confused there. So this is 144 plus the 180. That's going to give you a 324. So this is going to be 324. You can take that over. And then if you divide by 12 on both sides, divide by 12, divide by 12. Let's see here, 324 divided by 12. Well, this is a negative, so it's a negative 27. So this whole thing here is going to give us a negative 27. That's our value for t. So our value for t here has to be equal to negative 27. And remember, our analogy was that we have an equation here, and we need to work out a value for t where the equation has one solution, because a tangent and a graph will only meet once. The reason we could not equate this equation to our equation of f is because our equation of f is a cubic function, and that was just going to be something that you cannot solve at grade 12 level. So that's how we got our value for t there. So now we need to work on question number 11. Question number 11. Oh, what do we have here? It looks like we have applications of calculus, most definitely. So this question here says a rectangular milk carton has a square base which holds 1 liter of milk, and then it is specially designed. It has a specially designed top. It has a specially designed fold-in top. The area of the cardboard used for the top is 3 times the area of the base. Yeah, I mean, we can see that 1, 2, 3 is 3 times the area of the base. I mean, hello, duh. But excuse me. Anyways, here it says show that the total surface area of the carton is given by this value. So the only thing is, you want to, let's put these dotted lines here. It will definitely make our life much easier. Let's put that there. This is not very much to scale, but oh, why did I have to do it like that? That's so here what we need to keep in mind is, I mean, clearly our shape has like many different sides. So with, they said this is 1, 2 and 3. Well, technically, yeah, we have 3 of these, and then we have the bottom, and then we have the surrounding. So technically we have 1, 2, 3 sides. Let's put, we have 3 sides, and then 4 around, so plus 4, and then 1 at the bottom. That's like 7 sides to take into account. We need to work out the area of the different 7 sides, and then we just need to add them together. Let's just see that again. It's 4 around, yes, and then we have, no, it's 8 8 sides. So let's just be quick. So here we know the bottom part is clearly going, the area of the bottom part is x times x, so that's fine. So the bottom, let's put here the area of the bottom is basically x times x, which is x squared. And then these 3 parts here, 1, 2, 3, it's gonna be the top part, it's gonna be x squared multiplied by 3. Reason is, you see, they said here the area of the cardboard used for the top is 3 times the base. So the base is x squared. So here 1, 2, 3, it's going to be x squared times 3. And then the area around, we know it is basically just x times h going up, and we have 4 of them, you see, x times h. So we have 4 sides like that, because you see this is also x times h. You see, so all the sides, it's just x times h. So we have 1, 2, 3, 4 sides like that. So let's put here around, we have x times h multiplied by 4. Okay, so the total surface area, well, technically, I mean, let's just write it out first before we worry about the h and stuff. So for 11.1, we technically have the 3 things to add. We have 4xh plus 3x squared plus x squared. Well, we can just make that 4x squared. So this is equal to our surface area, you see. Well, let's write surface area first. This is going to be 4x squared if you want, plus 4xh. And so the issue now is we need a value that, we need an expression for h. And the only thing we have though is they gave us the volume. You see, they said here this volume is 1 liter. So you want to remember that 1 liter is equivalent to 1,000 units cubed. In this case, we don't know if it's in, let's see here, 1 liter of milk. Yeah, so this is 1,000 units cubed. You see, that's what a liter is. The volume here is 1,000 units cubed. So we have V as 1,000. So we can basically use that to eventually get a value for H. Meaning here we know that our volume, whatever the volume of this carton is, we need to work it out. So working out the volume of this thing, well, it's technically going to be the base, which is x times x multiplied by the height going up. That's going to be the volume of this shape here. The volume is going to be the base, right, multiplied by height. Area times height. Goodness, come on, bro. It's gonna be the area of the base. Yes, that's why I wrote base. I meant area of base. Yes, I was right. Area of base times the height, which is having a t there. So the area of the base is just x times x, and then the height is just h. So you see that's the volume, which is equal to 1,000. And if you isolate h here, you're getting that h is equal to 1,000 over x squared. Voila. Okay, so let's move on now. What do we have now? H, we can rewrite it then as 4x squared plus 4x. H is going to be 1000 over x squared. If you simplify, well, technically we're going to have 4x squared here plus 4000x over x squared. 1x cancels 1x. That's going to be like 4x squared. 4x squared what? No, plus 4000 over x, which is exactly what they wanted. So the surface area in terms of x is definitely going to be that. So, yep, you get your marks and you move on. So the key thing was the 1000. You need to remember that. Remember, 1 liter is 1000 units squared, or cubed rather. See, 1 liter is 1000 units cubed. So if it was in centimeters, it would be centimeters cubed, going on and on. Or whichever way, yeah. 1 liter is 1000 centimeters cubed. But anyways, the next one here says, determine the dimensions of the carton so that determine the dimensions of the carton so that the amount of cardboard. Determine the dimensions of the carton so that minimum amount of cardboard is used. So technically, if we're going to use the minimum amount of cardboard, it means we would be considering the minimum surface area, because our surface area is what is contributing to the amount of cardboard that we use. So we just need to work out the minimum surface area in this question. So the minimum surface area, obviously all we need is the surface area formula, which we have. We're literally just going to differentiate it and equate it to 0 and solve for x and then get a value for x and h. That's literally all we're going to do. Stop shaking. So let's see here. Yeah, for 10.2, that's 11.2, that's what we're going to do. 11.2. So we need to get our area formula, this one here. Well, before we differentiate it, we have to put it into standard form. So meaning this is going to be 4x squared plus 4000 with x to the power of -1. And then, so if we now differentiate this, and don't mind how I have SA here, it's really not a big deal. So differentiating this is going to be 8x. Here it's going to be -4000 x to the power of -2. Equating this to 0, we are seeing that getting a value for x here, we may need to take the x under again, so that it's like x squared. The reason for doing that is you may be thinking, are we going to eventually have cube somewhere? Maybe, but let's take this over first. This is going to be 4000 over x squared. This is like 8x over 1. So you can see we can cross multiply here. 1 times 4000, that's like 4000. 8x times x squared, that's 8x cubed. Divide by 8 on both sides. That's a weird looking 8. So let's see here, 8x cubed, 4000 divided by 8, that gives you 500. Okay, I think I should have worked that out mentally, but why? We have a calculator, you know, we should use it. Our value for x, let's try and not oversimplify this. For 500, yeah, it's 500. It is. So here, if you cube root 500, shift cube, our answer, it's gonna give you 7.94. You know, I mean, you just take it as it is, 7.94. So here x is 7.94, and luckily you see we have an expression for h already. So you can just say here h is equal to 1000 over x squared according to that, which is, you could even do it like this, over 7.94, the whole thing squared. Okay, let's see here, 1000 over 7.944, the whole thing squared. Okay, 15.86. 15.86 is our final answer. 15.86. So those are our dimensions. The value of x has to be that. The value of h has to be that. However, you may be thinking to yourself, but is this the only answer? Well, we could basically just look at it a bit more. Yeah, these are our solutions for x and h. moving on to question, let's see what's next here. Question number 12 is the next thing that we have to do. So question 12 is quite dope. It's a probability question, clearly, and it's the last one. Yo, wow, it's literally, this tutorial is going to be like under 2 hours, which is like a record. Dope. But anyways, a printing company has 3 machines, machine A, B, and C, to produce banners. Machine A produces 20%, B 30, C 50. And then it says 2% of machine A copies are not perfect, 3% of B are not perfect, 8% of C are not perfect. Let P be perfect and NP be not perfect. And then represent the information by means of a tree diagram. Okay, so this tree diagram is going to be, oh no, this is the second last question. Oh wow, I spoke too soon. Oopsie. So question 12.1, we need to draw a tree diagram. So drawing a tree diagram, it is, yeah, it's not bad. Like here, our information, we can clearly see we have 3 machines. They each produce a certain percentage. And then from that produced percentage, they basically have ones that are perfect and ones that are not perfect. So basically what I'm trying to say is, let me put this, what's the easiest way I can put it? Let me put it next to each other. Yeah, let's see there. So here, let's see, so 3 machines, right? We can basically start off our tree diagram like this. Machine A, B, and C. So machine A, B, and C. These 3 machines, they basically produce, what did they say they produce? They produce 20%, and then the other one produces 30%, and the other one 50%. So obviously you can see it adds up to 100. So here for C, we know that you can write it as, if you want to write it as a percentage, feel free, don't forget the percentage symbol. This is like 30, this is like 20. Okay, perfect. Now the idea is they each produce perfect and not perfect, perfect and not perfect, perfect and not perfect. So let's put that there. NP, P, NP, P. Oops, I was about to make a mistake there. NP, P. Now the big idea is our outcomes, right? You need to note those outcomes. These outcomes, it's basically going to be machine A and not perfect, machine A and perfect. Then here it's going to be not perfect from machine B, and then perfect from machine B. And then this one is going to be not perfect from machine C and perfect from machine C, of which these all have outcomes as values. So they say it for A, not perfect. For A, it is 2%. So 2% is not perfect, so meaning 98 is perfect. You see, automatically we can say 98 is perfect. For B, they say 3% is not perfect. So you see here, if this is going to be 3%, it means that this has to be 97% perfect. C, 8% is not perfect. C is messing up. 8% is not perfect, so 92 is perfect. Okay, so the outcomes, it's literally multiplying this and that, 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 this and that. So let's multiply those figures. So this is 8% and this is going to be 92%. So remember, in your calculator you have to put the percentage symbol. So the reason I'm doing this and putting in the values as well is because you it will help when you simplify. So here I'm just going to multiply 20% times 2%. Let's see, 20% times 2%, that's, you can basically put this as 1 over 250. That's fine. And then I'm just going to do the same for every one of them. Like here, 20% times 98%, 20% times 98%. That's like 49 over 250. 49 over 250. And let me just do that for the others. There we go. Now the big idea is all these figures. You see, we're just saying this times that gave us this. This times that. 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 Now all these values have to add up to 1. And they do. And I always prefer doing this before jumping into other questions on the tree diagram, because your other questions are all going to come out from this. So that's your tree diagram for 12.1. It's just 4 marks, but the others are going to be super easy, because here it says a banner is selected at random from the total production. Calculate the probability that the banner selected at random was produced by machine A and is not perfect. So you see, no, machine B. What did I just read? We need to work out the probability that it is produced by machine B and it is not perfect. So all you want to do is go to your tree diagram. Machine B not perfect is just going to be 9 over 1000. So you see 12.2 is literally going to be 9 over 1000. That's it. You give an answer and you move on. You see, if you had not done this, now you have to look at it and calculate. Whereas if you have it done beforehand, you can literally just give your answers because it's all there. 12.2.2, this is 0.1. 12.2.2, this is saying probability, we should work out the probability that the learner, that the banner selected at random is not perfect. So literally all you do is you go to all the ones that have banners that are not perfect. You see 1, 2, 3, you see not perfect, not perfect, not perfect. These 3 probabilities, you add them up. You see, so the first one here is 1 over 250 plus 9 over 1000 plus 1 over 25, and then all this you want to put that in your calculator. Let's see, 1 over 25, 1 over 250 plus 9 over 1000 plus 1 over 25. This is going to give you 53 over 1000. You can just leave that as a percentage, or this, or a decimal. I just leave it as a fraction and I move on because ain't got no time to waste. So that's for 12. That's actually for question 12. There's really not much to it. It was simple, straightforward. You get your answers and you run, you know. So now for question number 13. Question number 13, we made it. It says, in a survey conducted by 220 grade 12 learners in grade 12. In a survey conducted by 220 grade 12 learners in a school, the following data was collected. So this data basically showed that you have boys and girls, ones that like ice cream and ones that don't. Weird people. How do you not like ice cream? Maybe you're gluten intolerant. Sorry. Yammer. But anyways, so you see here we can quickly just fill in our totals before even working out anything, because you need your totals. So 65 plus 30, that's going to give us 95, and then 70 plus 55, that's going to give us 125, and then technically, I mean, this is going to give us 85, this is going to give us 135, and then this is going to give us, so that's a 0 at the edge there, and then 9, and then 2 and 2. Yeah, because you see, you have to say 9 plus 2, that's like 11. But the problem is you have 10. So it's like 11 plus the 1 there, so it's like 12. And then you have a 1 there, and then it's like, I don't know how I'm explaining that, but it's weird. Anyways, we have our table now. It says determine the percentage of boys that like ice cream. Percentage of boys that like ice cream. Well, technically, what you need to think to yourself is percentage of boys that like ice cream. So we need to think to ourselves, I mean, firstly, with our question, right, how many boys do we have in total? We have 95 boys. So the percentage of boys that like ice cream is going to be 65 out of 95 times 100. And then this percentage, let's say here, it's going to be this value times 100. Because you see, I just did this 65 over 95. Let's say times 100. That's just 68.42. The question here is asking us for the percentage of boys that like ice cream. So we're talking about the boys only. So we have 95 boys in total. So you just work out how many boys like ice cream amongst those guys. And then here calculate the probability that a randomly selected boy likes ice cream. So firstly, we need to ask ourselves, how many boys like ice cream to begin with? We have 65 boys that like ice cream. But if it's just someone being selected randomly, it's 65 out of 220. So the probability that we pick someone that likes ice cream, that's a boy, is going to be 65 over 220, which is just 0.29, of which this we can round it off. We don't have to round. This is quite a big number, so let's just simplify it first. Let's see if this is simple. 13 over 44. Yeah, I would just leave it like that. If you want with probability, they usually have more decimals than usual, so you can round off to 4 decimal places here. This is going to be 0.2955. This is okay because, you know, probability is like a special child. So 3 marks. The next, they asking us here, are the events of being a boy and liking ice cream independent or not? Show all working. So the events are the events of being a boy and liking ice cream independent. So we need to think of what is the probability of being a boy, and then what is the probability of liking ice cream. You see, we need to get these two probabilities. So firstly, the probability of being a boy is 95 out of 220 people. 95 out of 220 people. The probability of liking ice cream, people that like ice cream, there's 135 of them. So it's 135 out of 220 people. So if these two events, they said, are these independent events or not? So what we know about independent events is that the probability of this times the probability of liking ice cream should be equal to the probability of, the probability of being a boy times the probability of liking ice cream. This should equal to the probability of being a boy and liking ice cream. If this balances, then we're dealing with independent events. So, I mean, we can just look at our table. The probability of being a boy and liking ice cream, it's 65 over 200 and what? 220. So the probability here is 65 over 220. The probability of liking ice cream, we say that's 135 over 120. The probability of being a boy, that's 95 over 220. Let's see if these match up. You see, in your calculator, just gonna put the 95 over 220 times 135 over 220. Well, that's giving us, like, sure, it's a big number, 513 over 196. No, 1936. 513 over 1936. This is definitely not equal to this. I mean, we can even check the decimal value. You see, it's like 0.26 something something something. And then this one, 65 over 220, that's, you see, 0.29. So you see, they're not equal to each other because, yeah, they're not equal. So they are not independent events. Oh my goodness. Wow, today we are moving. Like, I kid you not, most papers are like 3 hours. No. 6 hours, 5 hours. This is like less than 2, so this was dope. So yeah, for more tutorials on, like, you know, different topics and stuff like that, you can always look at the main channel, or you can just check on IG, this page. This is my IG page for maths, where I also post like more content there. So cheers. If this is helpful, don't forget to like, subscribe, and all that YouTube shandies.